All right, this is lesson 17, functions and relations. So key concepts. Functions are special types of relations in which the value of one number, an independent variable, affects the value of the other, the dependent variable. These relations are expressed as tables, graphs, mappings, and ordered pairs. So on the coordinate plane consists of two number lines that intersect perpendicularly, which means they intersect at right angles. The part of the coordinate planes are listed below. So this is the y-axis. So here's the y-axis right here. The quadrant 2, so this is 2. This quadrant 2. The origin is right here at the center. Quadrant 1. The x-axis. Quadrant 3. And quadrant 4. Okay. Each quadrant consists of an x value and y value in the form x comma y. The table below shows which values are found in each quadrant. So in quadrant 1, they're both positive. In quadrant 2, the x values are negative and the y values are positive. In quadrant 3, both values are negative. And in quadrant 4, the x values are positive and the y values are negative. If the x value is 0, the number is on the y-axis, right here. If the y value is 0, then the number is on the x-axis. Functions. A function is a relation where each value in the domain is paired with exactly one element in the range. The domain is a formal name for the x values, and the range is the name for the y values. Sometimes in a function, the y is replaced with an f of x. This is known as function notation. So for example, the function y equals 2x plus 4 can be written as f of x equals 2x plus 4. Definitions you must know on the Keystone exams include function, a relation between two sets of numbers where the domain, x values, do not repeat. Domain, all of the x values of a function. The domain can refer to one value or a list of all values of x. The domain of an equation includes all the values and is often listed by the minimum and the maximum domain values of the function. Commonly, their values are positive and negative, infinity. Range, all the y values of a function. The range can refer to one value or a list of all values of y. The range of an equation includes all the values and is often listed by the minimum and maximum range values of the function. Commonly, these values are positive and negative infinity. So example 1, determine if the data in the table below is a function. If it is, find the domain and range. So if I write the values as an ordered pair, I get 1, 76, 3, 93, 4, 82, 8, 89. Therefore, the domain is 1, 3, 4, 8, and the range is 76, 82, 93, 98. Since each value in the domain is matched with one value of the range, the domain does not repeat. The relation, therefore, is a function. Okay, example 2, explain the graph of the relation below. Explain how the graph represents a function. Compare each of the values of the points on the graph. Verify that there is no more than one point with the same domain values. So if I go along here for the x, I see one here, one here, one here, one here, one here, one here. None of these values overlap. Since no x values repeat, the graph represents a function. Another method of determining whether a graph represents a function is to draw vertical lines through the graph. If a vertical line intersects more than one point on the same graph, same time, then the relation is not a function. The vertical line test is a common test that is used. An easy way to use the vertical line test is to slide a sheet of paper across the graph of the function from left to right to see if the edge passes through more than one point on the graph. So determine if either of the following relations are functions. So I have A. So if I look at this, it looks like these 2 points right here would overlap. But this is an open circle and this is a closed circle. So that means it is a function. Okay. I can do the same thing here. So if I have a vertical line, it passes through these 3 points. This was an open circle, closed circle, open circle. Okay. So the vertical line test demonstrates that graph B is not a function because of the vertical line passes through over the area where x is less than 0. The line touches the graph at 2 points. It is worth noting that when x equals 0, the only y value that exists is at y equals 1. Okay, so 2, like this is okay, but 3 is not. Example 4, answer the questions that follow above about the graph below. Does the graph represent a function? Explain your reasoning. B, name a value that is not part of the domain. And C, is the value 2 included in the range? So for A, the graph is a function because no x values repeat. So if I go through, I have 2 here, but this is open and closed. 2 here, but this is open and closed. 2 here, but this is open and closed. Nothing here. And then this little function here. Okay. So this is also verified because of every point vertical lines only intersect the graph once. B, according to the graph, all values from -8 to 8, -8 to 8, so we're talking about the domain, are included in the domain except the values between 3 and 4, these values right here. There's no line that connects this, so these values are not included. Therefore, any value between 3 and 4 is not part of the domain. C, the range of the function includes all values from -7 to 7 except the values between 1 and 3. Therefore, 2 is not part of the range. All right, and that is the end of lesson 17. Go ahead and work on the exercises below.